Hello, class. Today we're going to learn about free fall. So far we've discussed motion only in the x direction. In this section we're going to focus on motion in the y direction. Free fall only occurs if there's no other forces acting on the object as it falls towards the earth. Near Earth, all objects experience a downward acceleration that we call gravity. That's right, gravity is a downward acceleration. The higher you drop an object, the faster its velocity will be just before it hits the ground. In this course, we'll define up as positive and down as negative. The apple motion picture on the right shows a snapshot at equal time intervals of an apple dropping. The larger gap you see near the bottom indicates that the apple is accelerating downwards. The neat concept about free fall is that the mass of an object does not affect its rate, meaning acceleration falling towards the earth. Any objects dropped from the same height on Earth will fall at the same acceleration of 9.8 meters per second squared. However, air resistance creates drag on an object and slows its net acceleration down, as seen in the figure on the left. As previously mentioned, the acceleration downward is 9.8 meters per second squared, which we define that value as gravity. The picture on the left shows a person, let's say Mr. LaRock, throwing down an object from the top of the tower. This snapshot of the ball at equal time intervals of 1 second shows the distance increasing due to the acceleration of gravity. What do you expect the position time graph of the ball motion to look like? A parabola, because the ball is accelerating downward. We'll use the y variable to indicate the motion of moving up and down. There are two changes to make when using kinematic equations for free fall. The first change is to replace all x variables with y variables to indicate that the motion is up and down. Second, replace acceleration in the x direction with negative g. The variable g stands for gravity, the value of 9.8 meters per second squared. When solving motion problems, keep these equations nearby. Exercise E. Two small, heavy balls have the same diameter, but one weighs twice as much as the other. The balls are dropped from the second-story balcony at the same exact time. The time to reach the ground below will be, and of course we're going to assume minimal air resistance, nearly the same for both balls, because both objects are falling at the same acceleration, and if we ignore air resistance, any object, no matter its mass, will fall at the same rate. Example 210. Suppose that a ball is dropped from a tower. How far will it have fallen after a time of 1 second, then 2 seconds, and 3 seconds? And of course, we're going to ignore air resistance. Step 1. Write out your givens. The initial position we're going to assume is 0. So we're going to take the first time, which is 1 second, and because that is dropped, the initial velocity in the y direction is 0. And we're trying to find the final position, which is y. Which of these three new kinematic equations for free fall do you think we use? Correct. Y equals y naught plus vy naught t minus 1/2 gt squared. Now cross out any variables that equals 0, which is y naught and vy naught. Then simplify the equation to get negative 1/2 gt squared. Now we just need to plug and chug. We'll get an answer of negative 4.9 meters. The negative sign is just relative. It means below our reference point at the top of the tower, as seen in the picture in the upper right-hand corner. Now use the same equation to solve how far it will drop after 2 seconds. We get negative 19.6 meters. And now after 3 seconds, we get negative 44.1 meters. Because the ball is not falling at a constant speed, but accelerating at the rate of gravity of 9.8 meters per second squared, we can visually see from the picture that the gap is growing after each second. Alright, next example. Now let's suppose the ball in the same example is thrown downwards with initial velocity of 3 meters per second instead of being dropped. Part A, what then would be its position after 1 and 2 seconds, and what would its speed be after 1 and 2 seconds? First step for part B, let's write out your givens. Because the ball is not dropped, but actually being thrown downwards, we need to write negative 3 meters per second. For the first time, it's 1 second, and again, we'll assume the initial position to be 0, and we're trying to find the final position, which is y. We'll use the same equation, and now we just need to cross out any variables that equal 0, which in this case is just y naught. So now this equation can be reduced, and then we just need to plug and chug. Take careful note of how the negative signs are applied in this equation. And we get negative 7.9 meters, which means the ball falls further down if we were to throw the ball downwards instead of just dropping it, which makes perfect sense. Now for 2 seconds, the ball drops even further, at negative 25.6 meters. For part B, what would its speed be after 1 and 2 seconds? Write out your givens, but with a new variable we're looking for final velocity. Which kinematic equation do you think we should use? Correct. Vy equals Vy naught minus gt. Now just plug and chug. And we get negative 12.8 meters per second. And then for 2 seconds, the final speed of the ball dropping is negative 22.6 meters per second. The negative sign refers to the velocity pointing downwards, which makes sense because the ball is moving downwards. Now a different type of example. A person throws a ball upward into the air with an initial velocity of 15 meters per second. Calculate how high it goes, and again ignore air resistance. Write out your givens, which the initial velocity is positive 15 meters per second, and the initial height will start at 0. What you need to remember from this example is that the velocity in the y direction at the highest height is 0 because the ball is changing opposite direction. So the ball pauses for an instant. It happens so fast that it's hard to see with our naked eye. Now the variable we're trying to find is final height, which is the variable y. Can you guess which kinematic equation to use? Right again. Vy squared equals Vy naught squared minus 2g times y minus y naught. Now cross out any variables that equal 0, which is the final velocity and the initial height. So our equation reduces down to 0 equals Vy naught squared minus 2gy. Now solve for the final height, which is the variable y, to get Vy naught squared over 2g. Then we plug and chug, and we get an answer of 11.5 meters as the maximum height of the ball. Now same example, but how long does it take for it to come back to the hand? Again, write out your givens, but this problem we're solving for time, and the final height is 0. Now which kinematic equation should we use? Correct again, y equals y naught plus Vy naught t minus 1/2 gt squared. Now cross out any variables that equal 0, which is the initial and final position. So our equation reduces down to 0 equals Vy naught t minus 1/2 gt squared. What other variables cancel out? That's correct, time. So now our equation reduces to Vy naught minus 1/2 gt. Now just rearrange this equation to solve for time. Then we can plug and chug to get a time of 3.06 seconds for the ball to go up and come back down. Here are two misconception problems. Number 1, the acceleration and velocity are always in the same direction. Number 2, that an object thrown upward has a 0 acceleration at the highest point. For number 1, an object slowing down always has acceleration and velocity pointing in the opposite direction. And then for number 2, the acceleration of gravity is always the same value and will not change no matter where the object is during free fall. And that is, of course, if we're ignoring air resistance. Alright, last example. A person throws up the ball into the air with an initial velocity of 15 meters per second. But now, how much time will it take for the ball to reach the maximum height? And then part B, the velocity of the ball when it returns to the thrower's hand. Again, write down our givens. The initial velocity is positive 15. The final height is 0 because it's at the maximum height, and the initial height is 0. And we're trying to find time. Which equation do you think we use? You got it. Vy equals Vy naught minus gt. Now cross out any variables that equal 0, which is just the final velocity. And now the equation reduces down to 0 equals Vy naught minus gt. Now rearrange the equation to solve for time. And you plug and chug, and we get 1.53 seconds. Notice that this value is half the value of the complete trip of going up and down, which was 3.06 seconds. For part B, what is the velocity of the ball when it returns to the thrower's hand? The givens are slightly different, with the final position now at 0, and we're solving for the final velocity of when the ball hits the hand. Now don't make the common mistake of saying 0. We want to know the final velocity right at the instant it hits the hand, which is going to be greater than 0. The equation we use is Vy squared equals Vy naught squared minus 2g times y minus y naught. The variables that cancel out is final position and initial position. By golly, look at that. The squares cancel out, and the final velocity equals the initial velocity, which is 15 meters per second. So anywhere at the same height, the magnitude of the velocity is equal, but the direction is an opposite direction. Now let's say we have two balls are thrown from a cliff. One is thrown directly upward and the other one directly downward. Both balls have the same initial speed and both hit the ground below the cliff, but at different times. Which ball hits the ground at the greater speed, ignoring air resistance? Both the same, because the velocity of the ball being thrown up will have the same velocity at its return height but in opposite direction, which is identical to throwing down a ball at the same velocity. Here's a picture showing of what I'm talking about and things to remember about free fall. Number 1. The velocity in the y direction at an object's maximum height is equal to 0, as shown at point B. Number 2. The velocity in the y direction at point A and point C are equal, but in opposite direction. And point 3. The time interval between point A and point B is equal to the time interval between point B and point C. Last question. If the velocity of an object is 0, does it mean that the acceleration is 0? And if the acceleration is 0, does it mean that the velocity is 0? For A, no, an object thrown upward at its highest height has a velocity of 0, but an acceleration of 9.8 meters per second squared. And for part B, no, an object moving at a constant velocity will have an acceleration of 0.